Do 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 do. Kirk. All right. So on day 3, we did a practice in class. So we're kind of jumping to day 4 here, which is our next lesson, our next new lesson. And today we get to learn about combining like terms, which is one of my favorite algebraic topics. So let's dive right in. Our objectives is going to be that you should be able to combine like terms to create equivalent simplified expressions. And you should be able to identify a like and an unlike term. Okay. Terms are very similar to objects. So we're going to start in Miss Vara's science class. They've collected the following items on a nature walk. We are going to group the like items together and determine the total number of each item collected. Now, when I say group, I truly mean group. So let's actually start to group and circle all of the leaves that are kind of adjoining here. And then we'll circle or group all of these as well. And then we'll count them up. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 leaves. Okay, and then over here I've got 1 flower, 2, 3, 4, 5, 6, 7. 7 wildflowers. Okay. Now you might be thinking this is weird, and why am I just circling flowers and leaves? But this has a lot to do with combining like terms. Algebraic terms can be grouped in a similar way by combining the like terms. Okay. So I want to show you what it is first before we identify a like term. But you can see here I've grouped these flowers into different groupings. And if I labeled them algebraically, I might label this as like 1 flower. Well, we learned last lesson we don't need that 1 in front of it. So this would be like an F for flower. So 1 flower plus 2 flowers plus 3 flowers plus another flower made 7 flowers. So if I were writing that out in an expression, it would look something like this: 2F plus 3F plus F. And you may notice that's going to end up equaling 7F. And you may notice it doesn't matter, this first number here, this number, that coefficient, doesn't matter. All that matters is that they all have this letter F. If they have the letter F, then I can group them together and add them together. Those are like terms. It's kind of like organizing your room or organizing a set of items from nature. You put all of the things that are the same together. All of the t-shirts go in one pile. All the long sleeve shirts go in a different pile if you're cleaning your room or folding laundry. That's kind of the same idea with combining like terms. Now, if I was combining 2 things that didn't match, like a flower, so let's do a third color here. Like let's say a flower and a leaf, that would be an F plus an L for leaf. But those aren't the same things. I can't put flowers and leaves together. That doesn't make sense. I can't say that I have 2 flowers or 2 leaves. So these are unlike terms. I can't do that. These are unlike terms, and I cannot combine those. Okay, so now let's get into the definition. Algebraic terms are considered like terms if they have the same variable with the same exponent. And that's very important, this exponent part, because it's saying that an x and an x squared, or to the power of 2, are not the same thing. They are not like. Yes, they're both x's, but they don't mean the same thing. And that is because, if you remember, our powers, this is really, x squared is really x times x. We're kind of doubling, even bigger, this object. So if the x was a leaf, let's just say it was this leaf right here, x squared would be this leaf right here. They look very similar. This would be x and this would be x squared, but they are very different sizes, and so therefore I cannot combine them because they are not the same. In order to put them together, they have to be the same variable and exponent. Constants, or just numbers, are like because they do not have a variable. So if you have a number all by itself, like a 7, and you're adding it to a 9, these are like terms. But if you're adding it to a 2x, that is not a like term. And we're going to see what that means on the next slide. All right, so for each set of terms, we are going to circle the two that are like and cross out the unlike term, and then we're going to explain why. So we have to have the exact same variable. So I do not care that this is a 3 and this is a 4. That's not what I'm comparing. I'm comparing the y's. So 3y and 4y are like, and 3x is not like, because 3y and 4y have y. 3x has an x. Okay. On our next one, I've got 10x, 5x, and 2x squared. Well, my x's go together, and my x squared is unlike. Okay? X is not the same as x squared. So that's why I put them together. And then in the last one, I have 10, 7x, and 7. Well, my 10 and my 7 are going to go together, and my 7x will not. Okay? And that's because they are constants. No variable. Okay? And my 7x does have a variable. All right, in this next part, we're going to use algebra tiles to model the expressions. The first one's been done for us so that we can combine like terms. So here we can see we've got 1, 2 x's, and then over here I've got 3 x's. If I put all my x's together, I would end up with 1, 2, 3, 4, and 5. This is 5 x's. Then over here, I've got 3 singles, and then I have no other singles in this area. So my leftover amount is just plus 3. And that's my equivalent expression. That is the same thing as 2x plus 3 plus 3x. What I did was I took these x's and I put them together, but the algebra tiles helped me. Okay, so let's try it again. So over here, I've got 4 singles. Then I have an x. And then I have 2 more x's. And a single unit. We're going to put together all of our things. So we're going to put together all these x's to make 3 x's. And then I'm going to put together all these singles to make 5 singles. Okay, this next one is a little bit trickier because I have to pay attention to my signs. Remember, you always include the sign in front of the number if there is one. So that's a positive x because there's nothing there. These are 3 positive units. Then I've got another x, positive, and then a single negative unit. If you remember from the beginning of the year, a positive and a negative make 0. Okay, which means that they cancel each other out. It would be like if I did that 3 minus 1, if I put those two things together. That makes just 2. Okay, So if I put my x's together, I get 2x. And if I get rid of one of my x or one of my units, because I have a positive and a negative, I'm left with 2 units. Okay, now let's start combining like terms without the model. So we can simplify algebraic expressions by combining like terms. There's that word again. It's very important. Okay. Okay, so we are going to go ahead and identify the like terms in the expression. We're going to be careful to keep the sign that is in front of the term, and we're going to use the rules for properties of operations as we combine the terms, knowing that we can rearrange things or regroup them as needed. Okay, so here's our example. So I like to use, similar to this example down here, I like to use shapes or colors to identify my pieces, or I'll use symbols like underlining. So I might box all of my X's, okay, including the sign in front, and then maybe I'll just underline my non-X's. And then I'll go ahead and use my properties of operations to kind of rearrange my work here. So I can kind of pull these guys together and do 9x minus 2x, and then I'll kind of pull these two together and make that 8 plus 1. So you can see how I'm kind of grouping these like terms together. And now I can go ahead and solve and do 9x, take away 2x. If I had 9 x's and I took away 2 x's, I would be left with 7 x's, plus 8 plus 1 is 9. And this would be my final combined like term. All right, so we're going to do this again. So you can see here, again, they're using that to identify it, and then we're going to combine them. So 11x and 9x plus 19. So now we can do 20x plus 19, and that is my simplified problem. So try the two on this page and come back and check in. So I got 9x plus 3y and 21c plus 6. Remember, I don't want answers, I just want simplified expressions. So I put together all my x's and I put together all my letter c's and my constants, and this is what I got. I showed you two different ways, one with the kind of circling or some sort of code or shape, and the other one by coloring. Okay, here are a bunch of practice problems. I would like you to go ahead and try all 9 of these. And again, just pause, try them, and then check in with me. Oh, I went through and I identified all my like terms, but then I wanted to jump in and check in with you. I forgot to tell you something about algebraic expressions, and it's kind of about the language of algebra. When we're using variables and constants, you want to put your expressions in order with your anything that has a variable first and then your numbers come second. So even though I have, I could do 5 plus 9 plus 11y, my final answer should have the variable and coefficient term first and then my constant term second. If you have something that has a hierarchy here with exponents, you always want to go the higher exponent first and then the lower exponent, or single constant number is last. Okay, so here I'm definitely going to want to put these two together to get 18x squared minus x, and that's going to be the order that you put it in. All right, I'm going to finish these up and then you can join me again. Okay, some of these got a little tricky because I had to pull out my memory of positive and negative numbers and use some number lines to get my answers. So I'm going to show you that real quick. Here's my answers. These are pretty basic, pulling together the ones that go together and then subtracting them or adding them. This is where it started to get a little funky. So here I had a negative 11 plus 5. And we haven't done that, and we have on a number line a long time ago. So I drew a number line. I put negative 11 on here. I added 5 to it and I got to -6. And that's how I knew that this was a -6. 21W take away 6. In this one, I had to use a number line again. I had 7Q and I had to take away 13Q, and I got to -6Q. So that's my answer here. On number 11, I had to do it twice. So I started at -4, and then I added 12, and then I took away 8. And yeah, and then on this one, they were all the letter D, and I ended up just with 10D, and those are my answers. So hopefully that helped you practice, and we're going to practice a lot more with combining like terms.